Good morning, Grid Connections listeners, and welcome back to Grid Connections Podcast, the official podcast of Grid Connections Consulting, where we discuss all things from clean energy to electric vehicles and the power grid, connecting all of them together. In today's episode, we take to the water with David Tyler, Managing Director of North America at Artemis Technologies, a pioneering company bringing high-speed electric hydrofoil ferries and commercial vessels to more people. Spun out of the America's Cup racing world, Artemis is leveraging cutting-edge aerospace and EV tech to transform maritime transit with quieter, faster, zero-emission alternatives. We dive into how these e-foiler vessels drastically reduce energy use, eliminate diesel fumes, and bring new life to urban waterways in cities like San Francisco, New York, and beyond. From real-world deployments and reliability engineering to fast-charging maritime infrastructure and the potential for smarter, more frequent ferry service, this conversation is packed with insight for anyone interested in the future of sustainable transportation. If you enjoy this episode, please share it with someone else who's passionate about clean mobility and leave us a quick review wherever you get your podcast from. Plus, don't forget to sign up for our new newsletter using the link in the show notes to stay connected with the latest insights in the intersection of electric vehicles, infrastructure, and innovation. With that, enjoy.
Definitely. Great to be here. Artemis Technologies is a leader in the electric foiling commercial vessels, and we're actually a spin-off from the Artemis Racing America's Cup Challenge. So we were competed in high-performance racing, sailing these amazing catamarans, sort of going 4 times the speed of the wind, 60 mile an hour. A huge jump in terms of efficiency and technology within high-performance racing. And so we founded Artemis Technologies back in 2017, ready to bring that technology from high-performance racing into the commercial maritime segment.
That's awesome. So I guess for those who might not be familiar, let's even peel it back a little bit. What is the America's Cup? Just in case people listening are not familiar.
Yeah, I guess the America's Cup is kind of like the blue ribbon event of inshore yacht racing. I guess it's kind of, a lot of people say it's the Formula One of yacht racing. So generally it kind of competes every 3 to 4 years, travels around the world, and it's really a technology challenge, very much like Formula One motor racing. Each time there's America's Cup, there's a new design rule, and that sets the parameters of the competition. And then there'll be a number of entries from different countries across the globe competing to win this title.
And so that's traditionally really famous, really impressive. I mean, you're totally right. I think a great analogy is kind of Formula One for the sailing world and for what you guys are doing. How did it come from that to the foil and there's a lot of different really cool technologies in your product. So I guess let's kind of break down what makes, not only is it electric craft, obviously, but like what is the different technologies that makes it really stand out from like traditional boating. I think for a lot of people, especially from the North America side, I live in the Northwest, so taking like a ferry is nothing like unused, like going to the islands and stuff. But there might be a lot of listeners who aren't as familiar with how that kind of plays into and how important electrification, and then also some of the other technology that you're putting into it that really makes it even more efficient, is having such a big impact on this product.
Yeah, I think we have as you say, we have this e-foiler technology, which is like a combination of a number of different subsystems. And the kind of game-changing technology within that is hydrofoiling. For those who don't know what that is, a hydrofoil is basically a wing under the water. So it's very much like an airplane. So as a boat starts to accelerate, creates lift, pops the boat up out of the water. And by flying above the waves, we're reducing the friction or reducing the drag. And that's really important when you're looking at electrification, because it means for a given volume of energy storage or battery, size of battery on board a boat, we can go significantly further and faster. And so what we did as a company was really take those efficiency gains created through development of foils in that high performance racing segment and bring them in commercial maritime. Because as you're very aware, people have they have concerns about range anxiety around electric vehicles. But that's even worse with boats. Water's 800 times denser than air. So simply putting in batteries in a standard vessel, like, thinking about I'm here in New York, NYC ferries running around, putting batteries in those boats, they're significantly impacted in terms of the range that they can deliver and the speed of operation. So fundamentally, electrification in that basic form doesn't really work for high-speed boats. And so what we've done is brought that hydrofoiling technology to effectively increase the range and operation of electrification of high-speed vessels.
And so, I guess I really want to talk about what's interesting about how you're obviously leveraging the hydrofoil technology, but how is Artemis like really helping with improved commuting? And what does that kind of, for people who maybe take a ferry, and especially I'd love to see more of these in the Northwest, because the ferries here, they're pretty big, they're pretty slow, they're very noisy, and they're very smelly. So I think there's a lot of really cool things. I'm excited with what your technology has to offer.
Yeah, there's lots of benefits, and maybe I'll talk a bit more about the other tech. So we have the foiling by flying above the waves, really reduces the kind of effects of seasickness and the accelerations
Yeah.
that people might feel. So it means it's a far more comfortable and enjoyable ride when you're on board. The e-foiler system also has an electric propulsion unit, which is kind of integrated into the foil under the water. So the boats are a lot quieter. And because it's completely electric, there's no diesel fumes. There's kind of that vibration from the kind of noisy diesel engines that you're kind of used to. And also the boats can operate at higher speeds, particularly in sea states. So it means that, your high speed or your ferry commute in the morning could be significantly faster and quieter and more enjoyable.
So, I mean, so far, how is like the industry in your conversations really embracing this? I mean, I know hydrofoils in some ways have been around, or kind of like they're really big for some products previously in the maritime space, but that plus electrification, I'm kind of curious to see or kind of hear more about what you're seeing from the market.
Well, it's certainly been a journey. We've been doing this now for 7 years, and I think my answer to that question 5 years ago would be very different to now. I would say that we're kind of taking a big leap forward because we're combining electrification with hydrofoiling. I think 5 years ago, I think maritime was, I'd say it's probably quite an old-fashioned industry, probably quite skeptical of new innovations. Complete opposite, I'd say, to the automotive sector or even aerospace, where they're always trying to push the boundary. They want the newest technology and they don't want to fall behind. Whereas the kind of approach within maritime and, a public ferry operator or a pilot boat operator, they're like, oh, not me, I don't want to be first. They want to see it, make sure it's working, it's reliable. And so trying to talk to customers about this novel technology when we first started was quite tough. And I always like to talk about, a good friend now who's based in Belfast Harbour, where the company is based in the UK. They run pilot boats, and they were really kind of skeptical of the technology and what we were doing. And it was only once we launched the first vessel 3 years ago that they were kind of like, oh, wow, I get it now. That's absolutely incredible. It's going to completely change the way we do our operations. And I think that's a bit of a journey that we've been on. And we've launched over 10 vessels now, been on the water for over 3 years. And a critical thing for getting the market to embrace the technology is really taking it to the market. So we're in the middle of a North American tour, taking our boats around the US and now Canada to Miami, New York, San Francisco, Seattle, these places where there are big ferry networks and people really do rely on those vessels to get to work for lifeline services and just really to live their everyday lives. And I think once seeing the videos is one thing, but actually getting them on board, it just, they're completely blown away by it.
Yeah, and I think that was one of the reasons I was really excited to talk to you and your team is there's been so many different prototypes, whether that be automotive or even electric maritime. And so it's really cool to see a company that actually has a product that's brought to market. You already have some out there now, kind of expanding that. But let's kind of, I guess, I think we're also really curious about like the infrastructure to charge these and how that works. But let's just start kind of with the products that your team is offering and how you see kind of the hydrofoil and electrification technology kind of expand from what you offer today and then what you're looking to hopefully expand longer term.
Yeah, so we've really developed these e-foiler boats for operations that need to move people or goods fast. So it's high speed passenger ferry services, in places like San Francisco, New York, London, that are getting people to work. It's pilot boats that operate in ports and harbours that need to get pilots out to big ships so they can safely navigate them back into port. It's crew transfer vessels operating on offshore wind farms and providing crew services out to offshore energy platforms. They're kind of the critical target markets for us. We really wanted to develop a technology that could really support society and support those operations that are needed for us all to, either to live in our cities or to get the jobs done or to create the energy that we're going to need as a society. So I think there's kind of a lot of exciting additional benefits of the tech. So one of the things is because we're flying above the water, we produce very limited wake or kind of water wash when we're operating at high speed. So that means that we can avoid local speed restrictions, or we can operate at high speed in places that weren't possible before. So that really opens up the opportunity for new services. The boats as well, because they're very quiet as well, it means that where ferry services maybe weren't able to operate in locations or weren't able to start early in the morning, they can today because it's completely game changing. But also because we're using so much less energy because of the drag and the efficiency is so much better, it really changes the economics of high-speed operation too. So it makes certain ferry operations that weren't economically viable before viable today.
Yeah, let's kind of unpack that a little bit. So obviously the speed component is what really plays into kind of some of that. But I would imagine, obviously, for a traditional vessel, the diesel and all these other things just cause the expenses to skyrocket and possibly maintenance for kind of a vehicle that's probably under kind of stress like that. Can you talk a little bit about that? And then like what kind of speeds are we talking about for these boats compared to maybe traditional ferries?
The boats sort of operate between 25 knots and 35 knots, which I would say is quite typical. But I think the challenge with high-speed ferry services, the power curve for a fast ferry is basically exponential. When you go from sort of 25 knots here up to sort of 35 knots, it becomes very expensive to operate at those high speeds. And that's part of the reason why a lot of ferries don't do that, just because the economics don't work. But the big benefit of our technology is once we kind of take off and we have kind of a very flat energy demand as we sort of get up to those 35 knot speeds. So it means that, yeah, we basically using our technology, operators will be able to increase the speed of their operations. And that can be a real game changer because even here in New York, I'm based in the Brooklyn Navy Yard. If you miss your ferry, sometimes you have to wait 45 minutes, an hour for the next one. But if we could be going almost 30% faster, providing more services to people, that will really start to, it will really start to become a real alternative to using the buses or the subways. Because people know that if they miss one, they haven't got to wait too long to the next opportunity to travel on the ferry.
Yeah, I think that's a great call out. So it's not just really the speed of the ferry itself, but it's actually kind of helps with the frequency and kind of the traveling if you're trying to plan to use one of these. I guess the next question would be like, I know with some of the larger, kind of slower traditional electric ferries, they pretty much just they have this really unique charging pad that kind of just comes up against the side of the wall and more or less kind of wirelessly charges. It depends on the model, but for some of them, that's how it charges when it comes into the port for people to get on and off. And then by the time it's loaded, it's charged again to go. So I think we'd be kind of curious to learn a bit more about how charging works for an Artemis vessel and what that looks like for an operator to kind of implement if they maybe don't have something in place today.
Yeah, we're really leveraging technology from the EV space. So the batteries, we developed our own battery and we're using cells from an automotive supplier. And we're also leveraging the technologies developed for electric vehicle charging. So on the EF12 range, there's two options. You can do a fast DC charge with a CCS2 connector, or you can do a slow AC charge as well. And then with the bigger EF24, the bigger 150 passenger ferry platform, we're going to be utilizing the MCS standard connector. We'll be able to charge up to 2.9 megawatts. So for both vessel platforms, it is a case of using one liquid cooled cable and being able to charge the vessel from flat to full in an hour.
That's wild. And I guess what right now is the range of a vessel? Because I mean, I'm sure you say it takes an hour to fully charge it, but a lot of the time you probably don't even need to fully charge it, just taking advantage of when it's right there in the port.
Yeah, exactly. It kind of depends on your timetable and your duty cycle and how you're using the boat. We have a range on the smaller boat of around 40 to 50 nautical miles, kind of high speed, foiling speed. So generally the most efficient operation is around 25 knots for that platform. But if you're going 6 knots, we can go, you can go almost double that distance going slowly. And then with the EF24 platform, we're able to get a bit more range out of that boat because of the size of the vessel, a bigger catamaran. And so we're able to foil for around 70 nautical miles at 25 knots.
That's
So
awesome.
the kind of means that you can go for 2 hours foiling continuously pretty fast. And that's great for operations like commuter ferry services because generally they have to get through that busy rush hour period in the morning. And then during the day, they're generally quieter. So there's opportunities to do longer charges. So when we model our operations for customers, generally you're kind of, you're delivering a service, you're intermittently charging when you're embarking and disembarking customers so you can keep the battery topped up. And then you're using a longer charging window in the middle of the day to make sure you're fully charged by the time that busy rush hour period comes in the afternoon, early evening.
Yeah, and I think there's some really interesting things that are kind of unlocked with this product, and there's a lot of other products you're looking to bring to market. So I'd love to talk about those too. But I guess to start, since we've been talking about specifically kind of the ferry model, like what are some like waterways or other potential markets that you think maybe have been underutilized that now leveraging this technology and this product at some of the operational costs that this really unlocks?
I think there's been a general movement to utilize waterways in a better way. San Francisco is, particularly I like to talk about that because we're based there. That's where we're really developing this America's Cup technology. I was based in downtown San Francisco, and I used to commute on the ferry over to Alameda where we had our America's Cup base. And where the geography makes sense, like in San Francisco, they've really looking to try and build that ferry network to try and connect new communities. As San Francisco is getting busier and busier, new residential communities are getting built outside the city. There's a lot of traffic, obviously, going down to San Jose and Silicon Valley, and really the kind of road and rail networks are oversubscribed, and the cost of putting in a new rail service or putting in a new bridge there is just astronomical. And so the fastest and cheapest way to add capacity is to put on new ferry services, and that's something that San Francisco Bay Ferry or WITA have really seen, and that's their vision over the next few years, is actually to try and expand and provide more opportunities and a better ferry service to people. And I think they publicly announced only last week that the ridership has bounced back after COVID. Is actually they've got increased ridership, the biggest ridership they've ever had. Bigger than the pre-COVID peak. So I think people like taking the ferry. They like being on the water. You can get your laptop out, you can have a coffee, you can sit down, you can relax. And it's a really enjoyable experience. We talk about the ferry factor. And it's not going to work for everyone. It needs to make for you in terms of where you live or where you work. But it can be part of the solution when cities are looking to try and decongest their roads and rail networks. For the right cities like San Francisco and New York, it really does make a difference.
Yeah, I used to go to New York quite a bit for work, but then also lived in the Bay Area for a little bit. And driving the 101 is definitely something that I dreaded. And so what I think is really cool is, personally, I'm actually working to get my pilot's license. And so I think when people talk about like new transportation opportunities in the Bay, I think the thing that's come up a lot are like eVTOLs. And personally, I think those are really cool, but there's a really hard argument for scale. And I think especially for what you're talking about, like when you have a ferry like this, especially if you're trying to go from like the East Bay or Southeast Bay, and with the speeds you're talking about, this to me, I think there's definitely an argument for like eVTOLs in certain areas for like point to point. But as far as like a commuter thing, the idea of like hundreds of these eVTOLs kind of going in the air in the morning and then the other way in the afternoon, I just don't think it's like realistically the most practical. But I think that was part of the reason that I was so interested to talk to your company too, was not only do you have a real product that you're actually kind of already developing and getting out in the real world, but it actually makes sense from that kind of commuter argument that I think has been one of the bigger proponents for like the eVTOL space. And you can actually do this at scale. And there's just a lot more flexibility without having to come up with all the additional infrastructure that you need for like landing pads and all these other things, dealing with ATC, God forbid, and all of that. I'm kind of curious, does that come up at all in your conversations with providers when you're talking about like the future and the impacts of transportation and how Artemis can really actually be a pretty effective way to increase sustainable public transit?
Yeah, definitely. And I think when we're talking to public transit agencies in particular, they're looking at a suite of public transport nodes, and eVTOLs are certainly part of that conversation. But I think you struck the nail on the head there. It's just in terms of the cost of infrastructure, the availability of land to actually have these helipads or eVTOL pads as well, and landing sites. That's one challenge. So from a capex cost perspective, I think our product really is exciting for people, because particularly when comparing to traditional fast ferries that are around today, the technology is a bit more expensive to buy, but you're saving so much on fuel because we're using anywhere between 70 and 90% less energy. So if you're talking about the ferries in San Francisco or New York, we're saving 7 figures a year in fuel generally. So it means that the payback can be within a few years. And because the total cost of ownership is so much less, we're actually talking to operators about expanding their services and expanding their fleets, but also looking to try and, some of these bigger ferries, they're quite busy in the morning, but then they're actually quite empty during the day. And you're kind of carrying that cost of having that big vessel all the way through the day, which is incredibly expensive. So the kind of cost per passenger mile for those sort of midday trips is kind of, it's kind of astronomical, really. It just doesn't really make any sense. But by having a fleet of 150 passenger ferries, having those available to you during those busy rush hour periods, and then being able to take them out of service during those quieter moments, can really change the game in terms of cost. And that's cost to the taxpayer, which obviously benefits everyone.
Yeah, and I think one of the other interesting things too, I know we haven't really discussed this at all, is given what you're talking about the scale, the cost of operations, and that flexibility, to me, there's actually also kind of like a decent kind of software logistics play with this too, where you could start kind of leveraging more live data. Like, okay, I'm just going to throw something out. Like Oakland to San Francisco in the morning's really busy, but then you've got this 6-hour window, and it's like trying to think of ways you could actually start doing exactly what you're saying. It's like, okay, we don't need the ferries doing Oakland to San Francisco. They could be doing San Francisco to, I don't know, somewhere else. And is that something your team's also kind of looking at, of like how to kind of, I think that's what's been really interesting in the automotive space is, has there been a lot of hype? Yes. But there is now becoming pretty strong, especially in kind of the commercial applications of like leveraging software to find not only going from like more of a reactive, proactive business model, but find those opportunities like, hey, this thing is down when right now we could actually be putting it to work over here for XYZ. Is that something that Artemis is also kind of exploring and looking at?
Yeah, I mean, we it's in conjunction with operators, because they have they have their different opportunities and challenges locally. But as an example, the ferry could be used to provide commuter services in the morning, but then provide whale watching in the during the day, and actually act as a tourism vessel, and then you're utilizing that asset the whole time. So I'd say that's kind of one example of what you're alluding to. So it's kind of like a follow-on from, we shouldn't be operating this big boat with 10 people on it. It's just costing a fortune. Let's go smaller. Let's provide more frequent service. So instead of getting 600 people to come and park their cars all at once and cause chaos in the car park, why don't we have 350 passenger ferries and leave every 15 minutes rather than every hour? And that's just going to speed up everyone's travel time and reduce the costs significantly. So I think we're having to talk with these kind of public transit agencies to maybe rethink their models, but also we have to talk to them about the way they procure their vessels and their technology as well. Because I think traditionally there would be a tender for a boat, and it's kind of, there'd be probably a price battle on delivering a passenger ferry, because really the technology, you couldn't really tell much difference between a lot of the ferries that are available in the market. But there's a difference with our proposal because we're a little bit more expensive, but then you've got to look at the potential OPEX savings over the lifetime. So you really need to look at the whole big picture approach. And that's an
Yeah, and
education piece, which we're doing at the moment.
for sure. I guess that brings up a question I have is with the hydrofoil, and this is my ignorance, I guess, on the product specifically, is that fixed or is that something that actually goes down? And the reason I'm kind of asking this is, does that impact the slips in certain spaces that the ferries can go into?
Yeah, on the EF12, on the smaller boat, the draft is 2.2 meters, so about 7 foot. So
Yeah.
that generally that boat can get into almost every
Yeah.
marina, I'd say. 2.5 meters is typical. And so there is the option of a retractable system on that boat. But generally, we try and advise customers not to have it because it's another mechanical. They're always complaining about service and
Yeah.
maintenance, access to parts, costs over the lifetime. So what we wanted to do was try and create a product that was rock solid and really easy to service and maintain. So on our standard EF12 with the fixed system, we just have the drive unit, which is integrated into like an SL right next to the propeller. So there's no drive shaft going up the vertical structure of the foil. There's just the cable going up the vertical into the power electronics and then obviously into the batteries. So we wanted to get as many of the mechanical systems out of that boat as we could. And then on the bigger ferry, with a bigger boat, you want to be able to operate in bigger sea states. So that has a draft of around 3 meters. So in the majority of places, again, New
It's still
York,
not
San
that bad.
Francisco,
Yeah.
there isn't really an issue with that draft. But in places maybe in the Caribbean where there are draft challenges, then there is the option to have a retractable system.
No, that's great. I guess, are there any other examples, kind of like what you were just talking about, of the motor placement, that how your team's kind of designed for really trying to make the boat as simple and kind of as reliable as possible that you can share with us?
In terms of what we've done in terms of the development of it. Well, I think that the main one really is that having that submerged drive unit, so you don't have to have that drive shaft. That's really the critical one. I think in terms of there's general benefits of electrification, right, versus a nice,
For sure.
combustion engine. So we're kind of getting all of those benefits in terms of service and maintenance, number of hours. And kind of leveraging those kind of huge jumps and technology gains within that space over the last sort of 20 years. So the battery technology, the drive unit technology, we're kind of building on that experience. And
Speaking, I was just going to ask, speaking of the battery technology, I mean, is that what's really unlocked a lot of this? I mean, is this, with the advances we've seen, is this something that wouldn't have been possible 5 to 10 years ago? Or is it that, because I think it's really interesting because I get a lot of questions, especially in the automotive side, about the battery technology. And as the battery technology has increased in density, energy density, yes, that's unlocked more and more capability. But for the longest time, there's actually still been a pretty large opportunity for electrification. And I think it's really interesting talking about how your team has taken advantage of the battery density, but more importantly, paired that with hydrofoils to really get that gain, like higher efficiency, and make it a much more usable product. I mean, do you see the battery being still a pretty big limiting factor, or was it really once the hydrofoil was just kind of from day one in the design, the batteries weren't really as big of an issue as maybe it traditionally has been for maritime products?
Yeah, I think the big jump in efficiency and reduction in drag from the foils is the really game-changing part of this technology. I think we're always trying to improve the energy density of the battery. So we have a technology roadmap to integrate new cell technology, new cell chemistry as it comes to market, because we can deliver certain routes today. As I said, sort of 40, 50 miles, 70 miles on the bigger ferry, but in the future, we'd like to be able to service 100, 150 miles. And so that's only really going to come as battery technology really starts to improve. In the last couple of years, we've seen a 10% increase, I'd say, in energy density. So there's been some incremental improvements over time, and I think they're going to keep coming. And we'll look to integrate that latest technology into the solution. But the fundamental is that the foiling is kind of been a game changer for electrification of high-speed boats. And even in the future, as batteries become more energy dense, it's what operators are looking at today. They have the infrastructure availability for doing one boat, two boats, three boats, a small pilot. But when you're in New York and you've got a fleet of 38 vessels and you start looking at the kind of infrastructure required, you're always going to want to have the most efficient solution possible. So even if, in the future, say in 10 years' time, you'll be able to do some of those longer routes in New York with batteries alone. One, you're going to have a significantly higher requirement for charging power to deliver that. But also you're going to have a far higher cost of replacement batteries over the lifetime. So even in that case, you want to have that foiling solution because it does drive down your initial capex cost, but also your replacement batteries costs by tens of millions on those ferries.
No, that's a great point. I guess kind of going off of this, and this may be my ignorance in the maritime versus like aviation and automotive worlds. What is kind of like the limiting sea conditions or water conditions for a hydrofoil? Like obviously when it comes to aviation, like if you're flying a little Cessna, if you got more than a 15 knot crosswind or something, like no, you're not going to, you really don't want to take that thing out. And I'm kind of curious with hydrofoil technology, I've seen it be used in some pretty wild water conditions, but I'm just kind of curious if how that plays into this. For probably most ferrying situations, it's not, but like if you're going maybe from France to England someday and you're going across the channel, you might get into more serious, or like even in the North Sea, more serious sea conditions that might be an issue for hydrofoils. I'm just curious about that.
Yeah, I mean, we've engineered our foils for offshore operations. So what I'd say is kind of not every hydrofoil is designed for the same level of operation. But for
Gotcha.
us, initially, we developed our first system to meet the workboat code, the Maritime and Coast Guard Agency workboat code in the UK. And so that first vessel, Pioneer of Belfast, that was launched 3 years ago. That boat had workboat Cat, I think it's Cat 2 it's called, but basically it can operate up to 60 miles offshore. And so we wanted to, really utilize the benefits of foiling for those offshore conditions, because that's where it can be a game changer, because the energy consumption of our ferry in flat water versus a conventional craft at high speed is about 70% efficient. But as soon as you go into 1 meter wave, we actually become 80% more efficient. And as that sea state gets worse, the kind of efficiency differential compared to a standard boat just increases and increases. So going offshore or going in waves for electric boats, it's a bad scenario. It's a bad equation for those. And on the EF12 boat, it's really a question of.
I guess I'm not. I understand it requires more density, but as far as I've understood, that's kind of one of the misconceptions I think people see with hydrofoils is they see it only a couple feet out of the water, and so they assume, oh, it can't really go into like some serious chop or swells. But because you're getting like those added efficiencies instead of having to fight the waves, you can kind of go over them a lot more than I think most people realize.
Yeah, and I think what I'd say is our foiling boat always outperforms a displacement boat of the same size, no matter what the sea state is, because you're always getting that stabilization from the foil and the flight control system. So on the foil itself, we kind of have these flaps or ailerons, very much like on an aeroplane.
Right, which I've always thought such a cool thing about the tech.
As long as you've got kind of flow over that foil, then you're able to use those flaps to stabilize you. We've been out in the 12-meter boats in 4-meter waves. We've crossed the Irish Sea from Northern Ireland to Scotland, and we had Pioneer on our first run of doing that trip, and we had Seahorse, which is basically the exact same hull, same cabin. There's videos on YouTube to check out. and it was pretty big seas, up to kind of 4 meters, and everyone was being very ill on Seahorse, and we're having to transfer people onto the foiling boat to get the green out of their faces and then put them back. And so anyone that asks me that question, I just talk about that real life case study of us actually operating in those conditions.
Would you say like some of the challenge traditionally, or kind of the reason hydrofoils haven't become more common, was it just because of like the traditional additional engineering? I mean, talking about kind of the flaps and kind of that management of that. I mean, nowadays that's really not that complex of a system. But I think because I've always just thought this technology was just so fascinating, and the gains you get are so impressive. I'm curious if there's anything you can share of what maybe traditionally has been a bit of the issue. Is it because I think in a modern era with between the hardware and even like some of the stuff you can unlock with software for, I mean, we're even seeing this with planes and like almost leveraging similar to noise canceling technology to get rid of turbulence. You could do some similar things that are pretty cool going through waves or other kind of rougher conditions.
Yeah, definitely. And I think one thing I always see is on LinkedIn is people saying, "Oh, it didn't work in the 80s or 90s."
Yeah.
I'm like, well, that was quite a long time ago. Technology's come quite a
Yeah.
long way since the 80s, I have to say. Just because it didn't work back then, I think that's the case today. And I think on that point, there's kind of like fixed foils that are surface piercing. I don't know if you've ever been to
Hmm.
Greece. They have these things called the flying dolphins, and they have it's kind of this. It's called the Eurofoil design, but it had a lot of structure under the water. So there are a lot of appendages, and whilst you got a benefit in ride comfort, you weren't really getting much benefit in terms of fuel consumption and efficiency. And so
Gotcha.
that product didn't really take off in a big way. And then you had the jet foil, which was developed by Boeing. It was operating in the 90s. The US Navy were using them. There's still jet
Yeah.
foils being operated in, I think, Hong Kong, South Korea today. And that was a huge jump in terms of technology and innovation back then. And that boat used submerged foils with controllable appendages, so to provide a flight control system. And the challenge with that boat is that it kind of had a water jet system integrated into the foil, and it used jet fuel. So you got some efficiency savings, but the cost of the fuel was incredibly high because you had this water jet system. The foil wasn't as efficient as it could be. And so what
Yeah.
we've done with our e-foiler system is we have very efficient carbon fiber foils that have been developed through the America's Cup. And when you're efficient, they become very unstable. So you really need the active flight control system to be able to stabilize those foils when they do become efficient. I think it's that combination of composite engineering, being able to have control surface and complex algorithms to be able to control these boats in waves, combined with the miniaturization of the electric drivetrain and being able to actually house that next to the propeller itself. It means we don't have to have this drive shaft going up the vertical structure as well. And I think in the past, just managing that Z drive system mechanically, I think they
Yeah.
were breaking down a lot and it was causing a lot of problems. So we've really eradicated that issue with our tech.
That's interesting. I mean, kind of speaking to that, I could also see just like the torque. I mean, one of the big pros of electric motors is the torque. You can kind of unleash and use that however you want. And if you start putting them into drives, you can design it for that. But just in my experience, especially the more complex the drive is between the actual unit you're trying to move down, either through the water or down the road, it just puts more and more strain on the mechanical side versus just having more of a direct thing. I mean, do you have to do a pretty serious gear reduction, or is it pretty much like almost a 1-to-1 for the motor to the propeller?
Yeah, we have a gear reduction because of the
Yeah.
technology we're utilizing. We don't want we don't want the same prop speed as the
Yeah.
motor, so we do have to do that, and that's been part of the development especially in the early phases, is having that EDU or electric drive unit, making sure that as a unit is robust and reliable. Because we're developing this technology not for people that are going to be using these boats, every now and again at the weekend or just in the summer months. These are for
Right.
commercial operations, for lifeline services, and they need to work in every day in some pretty tough and challenging conditions. And so that's been our driver. in terms of development of our technology in particular, it would have been quite quick to get a foiling electric boat on the water. But that doesn't,
Yeah.
that's not what's required. You need that robustness, you need that reliability, and you also need to meet the requirements of the maritime regulatory authorities, which is not always an easy feat, I can tell you.
Yeah, I guess that brings up a couple questions. One, given like the cooling requirements of the motor, because you're dealing with the water and it's going to be kind of partially submerged anyway with how you have it designed, I mean, is that actually giving you a natural amount of cooling for the motor, and then it kind of keeps what you have to do? I mean, to me, that actually is a huge advantage in a maritime application for commercial usage. Not that even in automotive they get super hot, but it is something you have to manage and kind of deal with. And it seems like having all that abundant water that's so much cooler, probably engineering wise, can be something you can really use to your advantage.
Yeah, we do. The kind of liquid cooling or surface cooling of that drive unit definitely does help. And then we can use the water to bring water into the heat exchanger to cool the glycol for the battery system as well. So we're
Oh,
utilizing
cool.
being in the elements of the water. But that's really a critical thing, is managing the temperature not over the motor but of the batteries, particularly when you're operating in places like the Middle East where they see very, very high temperatures.
And kind of going back to what you mentioned about like some of the regulatory hurdles, and kind of making sure you're meeting those standards, is that pretty universal, like internationally, or have there been kind of unique challenges maybe you've had to see coming more to the US side versus Europe or other kind of international markets?
No, it's not universal. So in the maritime space, it's basically the flag state sets the requirements.
Yeah.
I think the good thing for us is that we were based in the UK and we were working towards the Maritime and Coast Guard Agency's rules. And I'd say they probably have the probably highest threshold in terms of safety of operation. I think the fact the UK is an island, we've got the North Sea, we've got some
The
pretty
UK was known
challenging.
for its ships. Yeah.
Yeah,
Yeah.
exactly. I think we have that heritage,
Yeah.
obviously,
Yeah.
within the maritime space, both in terms of engineering and insurance and everything else. And the Lloyd's Register class society has really been driving things for a very long time in that regard. So we were always developing our technology to meet a pretty high safety threshold, which puts us in good shape when we look to implement our technology in other locations, including the US. But the challenge we had is that the rules weren't written for foiling electric boats. So there were some rules around batteries on boats, but generally the rules were behind the technology, where the
Yeah.
technology was in terms of practice. And so we've been part of consultative groups from industry to support the regulators in terms of framing those new rules to make them fit for purpose. But where there weren't rules, like for rules around the closed control system for the flight control, we really had to work closely with the class societies because the flag states are they don't have the internal expertise, so they're kind of saying no,
Yeah.
we're gonna assign that approval and sign off to the class society, so you need to kind of work with them on it. And so it's been like a bit of a collaboration working closely with them.
And has the electrification side been the biggest challenge for those kinds of concerns, or is it just the fact that you're dealing with electrification and foiling that's just a lot all at once?
I think it's a lot all at once, but I think
Yeah.
the electric, there was things in place around battery technology and electric drives and
Yeah.
things like that. So, um, yeah, there's been a wider industry adoption to electrification technology. The foiling is kind of something on top in addition.
Yeah. I know we've kind of talked about it more from the business perspective, kind of like the sustainability and efficiency, but I'm kind of curious if there's anything else you can share. Obviously, a big driver, a lot of cities have their own kind of sustainability goals, and same with countries and states. So I'm just kind of curious if there's any advantages. I mean, obviously there's advantages, but like what has really stood out about Artemis in that industry to really help these cities kind of achieve or kind of move forward with a lot of these sustainability goals they have?
And we're kind of glad you brought it up because I think the whole purpose of what we did this was to support decarbonisation of that sector. and going back to our heritage, we were racing in these amazing places. Bermuda, we were based in Bermuda for a number of years, couple of years, and we had these polluting sort of chase boats that were chasing around these high
Yeah.
performance catamarans. They were, we're spending a fortune on diesel. They were dropping oil into this beautiful place. It just, you felt guilty from doing that, and that's where we've come from. But you know, you need to develop something that makes sense for the customer. Otherwise, you can't change anything. And so
Right.
it's almost like I don't even talk about the environmental aspects of this technology anymore. I really need to prove to our customers that it makes business sense for them and that it's going to be sustainable. And so that's kind of that's what I really focus on at the moment. But yeah, all of these boats are zero emissions in operation. They're going to have a huge impact in terms of reducing both water and air pollution in the places where these boats operate, and it's a big challenge.
No, that's
It's a
great.
big
And
problem.
yeah, I think a lot of the automotive world gets kind of the attention for decarbonizing, and obviously there's a lot of benefits for electrification for that space. But I mean, if you look at the shipping, I mean, especially when you start getting to large cargo ships and stuff like that, just some of the diesel and things. But even then, the impact of smaller boats and being able to electrify them, and there's still such a large, even if the batteries aren't where people want them long term, there's still such a large opportunity kind of in the current space for maritime to be electrified. But I guess having said that, I'd be curious. We've also talked a little bit about what you see the future is, but like, what are some additional products and kind of like what you see the future of Artemis being moving forward?
So we just launched our first crew transfer boat. So this is hot off the press. I think there's going to be an announcement next week. So we're demonstrating that CTV up in Aberdeen with customers
Congrats.
there. So that's pretty cool. So that's decarbonizing of those daily crew transfer operations. So that's really
That's huge.
exciting. And then the first pilot boat is progressing, and that will be launched later this year as well. So really starting to kind of diversify the portfolio of the offer. And in the future, there's a lot of subsystem technology that could have application outside of our foiling boats. So whether it's the propulsion unit or the battery system, the collision avoidance system that we're developing at the moment as well, could support other non-foiling operations in the future.
Well, I'm kind of curious too. When you go to your website, there's some really cool, obviously, boats you currently have, and then kind of some other vessels. But obviously, coming from the America Cup background, I've got to imagine there must be something kind of going around your mind as to what, using all this technology, you could put it into a race boat, or what. I mean, what do you see as far as like the racing opportunities for this technology?
I think we're getting a trickle down benefit from that technology, and we have a consulting business. So we work with a number of the Sail GP teams. Some of them still use our simulator to do training.
Oh, gotcha.
We also provide engineering services to other high performance racing teams within that space. So from an engineering team and a company perspective, we're still in that area where we're kind of pushing the boundaries and the limits and developing the technology at the sharp end. And then really we're leveraging that experience and then bringing it into the commercial segment. So I think it's always going to be that trickle down. But I think that development of this technology for our application, I think there's going to be trickle down to other applications of marine operation, and hopefully driving the cost down of batteries, so electrification of recreational boats becomes more achievable and feasible in the future.
That's fair. I guess I do know, I believe it's called E1, where there is the racing electric series. And it
Yeah,
does also kind of use the hydrofoil technology with their boats, correct?
yeah, it does. It's kind of
They're really interesting designs because the foil's like pretty far back on the actual boat.
yeah, and I think that I would say that I wouldn't say that's the pinnacle of foiling engineering. I think that's more of a, they have a
Gotcha.
vessel, they have a design, and
Yeah, yeah.
I think they're creating entertainment, right? So we had something, when we were racing in the America's Cup. It was the best way to control those foiling boats would have been to have a computer doing it and have an autopilot,
Yeah.
but then there'll be no human error, and so the races will be incredibly boring. And so I think when you're looking at sport and entertainment, you don't want the cleanest, the best, most advanced solution, because then you lose all the interest, you lose all the excitement, because you want those moments of something breaking, or a human error in their maneuver or something like that, making the racing exciting. So I think we've got to be careful that we still keep that within the sport.
No,
But
that's fair. And
from
that's
the
kind of what I was alluding to. I was kind of curious on your thoughts of that, because there is kind of that balance as to, like, looking at your designs, they're beautiful and really interesting. But I was curious what, and I think that's really true. We're seeing with a lot of automation that it is turned to almost pull back on the fun, whether you're talking about that industry or other kind of race series. So I was just kind of curious. I mean, if you were to design your ideal racing boat real quickly, I mean, like, is there anything that you're seeing with that series that you would do differently that you could kind of share? Or?
I think our focus is on,
Or
it's not something we've really kind of, it's not
I
something
was
I
going to say,
guess
I
we've
mean,
really
for
kind of
you,
considered.
yeah, I mean, for you, do you find the America's Cup as kind of like the pinnacle of racing and much more enjoyable because of how manual it is still? And even though it is kind of on the cutting edge of technology, it's kind of that perfect balance of um, bringing new technologies, but also having influence over the destiny of the outcome.
I think the key thing in like America's Cup, like it is in Formula One, is that there's rule changes on a frequent basis.
Yeah,
Because what if you get, like Mercedes dominating F1 for 8 years?
right.
Lewis Hamilton's amazing, but I wouldn't say that was the most exciting period of F1,
Yeah,
just because one team was so dominant. And the thing you see in the America's Cup, I think the most exciting races are at the beginning, when everyone's trying to figure out how to use their boat, and that's when there is that human error. Um,
yeah,
Whereas when you get down to the end, it's kind of the team that wins the start generally wins the race, because they've learned how to use the boat, and probably comes a little bit less. There's that excitement in the pre-start, but then you kind of lose that. You lose that excitement during the actual racing itself. And my advice to like the America's Cup would be to probably have shorter races, because it is all about the start. That is the most exciting bit. That is probably
interesting.
that is where tactics come into play, and have more shorter races. I think that would be better for the viewers at home.
Well, David, I really appreciate your time today. I think that's probably a great place to end it at. We'll have information in today's show notes for Artemis Technologies, but is there any other way you recommend for people to reach out to you or Artemis to learn more about what your technology can do and kind of help them for any maritime applications they have?
Yeah, you can check out our website, and then also we have a really good YouTube channel which has hundreds of videos now about the technology and the different platforms, and some of those cool videos of us operating in some pretty big seas as well. So definitely go and check that out.
Great. We'll make sure to link those, but we'll have to have you again on soon, David, to kind of see the new boats and technologies it progresses. But thank you so much for coming on today.
Pleasure. Thank you.
Thanks for tuning into this episode of the Grid Connections podcast, brought to you by Grid Connections Consulting. We hope you enjoyed our deep dive into how Artemis Technologies is redefining the future of maritime transportation with electric hydrofoil vessels that are faster, quieter, and dramatically more efficient. If today's conversation sparked ideas or inspiration, share this episode with a friend or colleague who cares about clean energy, sustainable transit, or innovative electric vehicle tech. And if you haven't already, please take a moment to leave us a review. It helps more listeners discover these important stories. Lastly, don't forget to subscribe to our newsletter. The link is in today's show notes for regular insights at the intersection of electric vehicles, infrastructure, and the power grid, which can be all found in our newsletter. Until next time, this is the Grid Connections podcast, signing off.